Alrighty guys, so today I will be showing you guys how to remove a piston rod from this beautiful 1963 Rambler American. And this is the 330, by the way. Right there. 330. There was a 220, 440, 440H. This is 330. It's a very simple procedure. I've already removed the damaged one on the end here, but what I'm doing now is I'm checking the other ones to see if they're also worn out. But it seems that they're all pretty good. Still a lot of life in them. I don't know why just one of them is worn out like this. Possibly, a flaw in the engineering. This is the end that's furthest away from the oil, or just somebody put the wrong one in. I don't know, but just take a look at that and just see how damaged that is. Let me just try to adjust the brightness here. There. Now take a look at the other one. That's nice and smooth. Look at that. Let me just remove some of the oil here. See, that's nice and shiny. Nice and smooth. It's not what I'd like, what I prefer, but it's no problem. This is no problem here. But now, in order to remove the other ones, you just get a little piece of wood. You don't really want to hit it with the hammer because it might damage the threads, right? So you'll get a little piece of wood because wood is soft. A little block of wood like this. Really tight down here, guys. Sorry. It's a fucking rainy day. Halloween today. And then you put it there on the thread. What you'll do is you'll hit one side a little bit. You're just tapping it. You're not going crazy, getting rough on it. You're just gently tapping it. Then you'll maybe tap it twice on one side, twice on the other side. That ensures that it comes out evenly. Because if it twists, then if you just keep hitting one side, it might come out or it might not. And so, just one each side at a time. But what you can do is also, after you do that, you're not going to have, the great thing about this car, I originally said that we would have to remove the head gasket. I mean the cylinder head, the engine head, and therefore the head gasket as well. But we will be able to just change it through the bottom here. What you can do is you just push the piston up and then move it to the side, just as I've done here. Look, you see, this is the piston arm, or the rod, if you will. Right, and as you can see, this is, hopefully you can, but this is nice and smooth. I mean, there's actually a slot here, and that's where the oil comes in. Now, if the slot wears out, then the oil is no longer to go in there, right? It's no longer able to lubricate it, and then it just gets really bad fast, right? So that's what happened to me. But I'll just try to show you the little there's the actual bearing that sits on the metal. It's just basically a piece of softer metal, right? Let me just try to zoom in. Jesus Christ, man. Oh, come on. What the hell? Too much light. Guess you can sort of see it from there. You see there's a There's like a line. That's because it's two separate pieces of metal. And over there on the top, you'll see a little hole. That's where the oil comes in into the bearing, and you'll see there's this like a depression, a slot. That's where it goes into the rest of the bearing. Well, obviously, as this wears out, then that slot is no longer there, and this eventually will go metal to metal contact. That's pretty bad. I don't notice on this one there's a little bit sticking out, but they're all really good. It's just the one at the end here that got fucked up for some reason. I don't know why. I am going to remove the middle one, but just look, I'm just going to show you how I moved the piston to the side and how I can put it back. So, you know, when we're changing this, you know, you can pull it all the way down here. Don't pull it all the way out. I don't think it's even possible to do that, because then the piston rings will come out and you won't be able to put them back in. So, you know, just leave them up to here. But I don't think it's even possible to do that in this engine. It's like these guys think of everything. So I'll just pull it out like this. Remove the old one, or in the case on that side it's already removed. This one I'll just leave because it's just brand new. It's not worn out at all. This is a 50-year-old car. But like I said, these things used to be hand assembled. So maybe it was just one the worker fucked up. He was on a bad day or something. Probably his wife's fault. Halloween. But then after that, let's say this one, you remove it, put the new one in, then you just push the piston back in. It goes on top like that, then you push it back down on top of the crankshaft, just like that, right? Easy as that. That easy. There you go. You see? Damn, my hands are all dirty. But what I am going to do is I'm just going to compare the measurement of the good ones to the bad ones, because I might need, you know, there's oversized ones depending on if the crankshaft is worn or the rod itself is worn. Then you'll need bigger ones in the standard, right? So I'm just going to check that out. But I like to just put the other bolts that were here on the other ones. I'm not going to remove all of them, at least not now in the video, but just want to show you guys quickly. Still got to remove this one. But I probably will remove all of them just to check and make sure there's no other bad ones. But yeah, you see, it's very easy. This was a modern car that'll be full of shit here. Literally thousands, millions of pieces here, pipes and fucking sensors and all sorts of shit. Here it's just very simple, very easy, and that's pretty much what you'll have to do on the engine. Alright, so I'll just show you the bad one, how it looks. And in this car, I just made a drawing here. The little balls, remember I told you there's like a little rounded part. It goes facing the back, and the 63 Rambler American 330. That's probably the same on the other models. I don't think they would have changed that. But and they're all also numbered, so just remember to put them back in the right place. Number 6, 5432. The one problem that I had here was the one. Here's the metal piece that goes inside. Do I have the? I don't think I have the other part around here. The bearing cap, right? But so this is the actual bearing here. Just a half slot, as you can probably tell, but you see, it's just really thin. And there's supposed to be two halves. The other half is just completely gone. There's nothing left, right? So that's where we're standing. Once again, I already ordered a new set from egg. It's a funny name, EGGE egg.com, but you can get piston rings, pistons, camshafts, all the parts for the engine off of this site, this website. But there you have it. The only other thing that you could possibly have to do with this engine is timing of the valves, right? Valve adjustments. On the DeSoto there, you're actually able to remove the all of the fenders from the front so that you have direct contact to the engine. On this car, unfortunately, I don't think you're able to do that. The inner fenders don't come out; they're welded to the frame, which is unfortunate. So it's really tight in there because it's at the sides, right? The valves are at the side of the engine. Maybe I'll talk about that at some other time. But yeah, here's where we're at, and I'm using a micrometer. Sorry, not a micrometer. It's called a vernier dial. You can't just use a ruler. This thing is just more accurate, and I might as well mention this, right? Do a complete video. This vernier dial here, it's called a vernier dial. Once again, VERNIER, vernier dial, or actually, sorry, vernier caliper. So caliper spelled CALIPER, vernier caliper. I think it's also called vernier dial, some other places vernier, whatever, but vernier, right? And what this is, it's just basically a ruler that's able to, just a very, very accurate, precise ruler, right? There's the, you just do the main reading here from the first line. Depending on your caliper might be different, but what struck me on this one is that it's only got 8 divisions on the inch side, whereas most of them have like 10 or 25. The more divisions there are, the more precise it is. Oh, fuck's sakes! I'll just try to It's not going to zoom in. But so the normal, if you will, part. It's just a ruler, and it's called the main scale. But on this little window here, there's a smaller scale, and the bottom it's centimeters. The top it's inches. But on mine, it's only 8. It's only got 8 divisions for the inches, and it's got 10 divisions for the millimeter. But both of them are still 9/10. So if you just close it, both of the smaller scales, or on the vernier scale, they're just 9/10 of 1 unit on the main scale. So for the centimeters, bottom one, there's actually this complete 10. The complete 10 divisions here. It's actually exactly 9 millimeters long, right? And for the inches, the entire scale, it's 9/10 of an inch. So 15. Actually, on this one, it's not. It's this one's actually less than half an inch on this one. Yeah, so that was my problem. Sorry, guys. This one's actually 1/16 under half inch, whereas in most of them they're actually 9/10 of an inch. I think 15/16. I fucking hate inches, but it's what most people use over here. Shut up. But like I said, most scales. But this, in all of the vernier calipers, what they fail, and I searched in the internet, and it's just a very simple result, and I couldn't find anywhere else. But I was able to figure it out, and on all of the vernier scales, independent of how many divisions there are, the entire top scale the vernier scale, sorry, not the top scale, the entire vernier scale represents the smallest division on the main scale, right? So in this main scale, the smallest division is 1 millimeter for centimeter for the metric system, and 1/16 on the imperial, right? So this entire scale here represents 1/16, and the entire scale on the vernier, in this case, it represents 1 millimeter. Now, if that being said, you just divide that by how many divisions there are. So in the case of the millimeters here, centimeters, the entire vernier scale represents 1 millimeter, right? And since there are 10 divisions, that means that each division is 1/10 of 1 millimeter, right? You divide 1 millimeter by each division to find out how much each division represents. So 0.1 millimeter. Now, for the inches here, in this case, there are only 8 divisions. So I will divide 1/16 by 8, right? And that will give me 1 out of 128. 1 out of 128. So 128ths of an inch. Each of the little scales. And then all you do is just find where it lines up with the a line on the main scale, and you just count them. So if it's the 4th line, then you just count 1, 2, 3, 4, and then you divide that by the number that, it's 4 out of 128ths, right? Then you just add that to the main reading. So in this case, I'd like to show you my method. And what's interesting about this is that if you just, that being said, that the entire vernier scale represents only the smallest division on the main scale, what's interesting is if you just, there's actually a demonstration on YouTube. I don't think you'll be able to see this here, unfortunately. But the only one of the scales on the vernier lines up to a line on the main scale. There's never 2 of them lining up. Some of them might almost line up, and then I think you take either you take the smallest measurement, but as you just move it a little bit, what will happen is the second mark, if you just close it completely, the caliper here, just close it completely. The first line on the vernier scale will line up with the first line, with the 0 line, in other words, of the main scale. And that's for the imperial or the metric systems here. But if you just move it a tiny bit, and you just watch it carefully, just move it until the second line lines up with the other line on the main scale. That's a little hard to explain, guys. Sorry, you won't be able to see there. So if I just move it a bit, the first line there, just move it a really tiny bit. First line will line up with the first line on the main scale. If I move it another little bit, the second line will line up with the second line, the third line with the third line, fourth line with the fourth line, fifth line with the fifth line, sixth, and so forth, until you finally get to the next division, right? So basically, with the smallest division on the main scale, you're able to move the vernier scale 10 times, or in this case 8 times with the imperial, right? There it is.